Dear students, welcome to another lecture in industrial engineering. We were discussing about outline process chart. Here I am showing you an outline process chart which is for the assembly of two plates with rivets. You see, actually, in the examples that we have seen earlier, we were not having these, these details which should be at the top of the figure. You see, it will be like this: part number, whatever is the number of the part, it should be given. What is then part name? You see here it is riveted plate assembly. Then location, where it is to be done in the assembly shop. Then method, whether it is present method or proposed method. That means old method or new method. So because we are studying this for method study, so we want to improve the method. So whether it is the existing one or the proposed one, that's what we have to specify here. And then the charted by, who prepared the chart. See here, A.K. Ramaya has prepared, and approved by, who has approved? L.M. Krishna has approved. Okay, so now you see, now here we are having three lines. This first line is for plate 1. It is cold worked steel strip, and its dimensions are given here: 30 maybe it is 30 inches wide by, or 30 mm by 4 mm, or I don't know, it can be any unit. 30 by 4. Okay, so we start here. See, what you have to do, you have to cut 250 long. This is the operation 1. Then it goes for drilling. 3 mm diameter holes, 2 numbers we have to drill. Okay, then you have to countersunk it. Countersunking means, the mouth of the drilled hole, you should make it a little conical with the help of countersunk tool. That is another operation. See, these are all the operations that you are performing on this plate 1 cold worked steel strip. And then you have to see whether any burrs are there. It is this is an inspection, so it is given as a square. This is the first inspection. So 1. See, at this place, so there is another part coming and joining. Okay, see, this is the plate number 2, which is cold worked steel strip, again 30 wide by 4 thick. So first you do another operation, which is that 350 long, you cut it, and then you drill holes, so like same here, 2 holes. And then see, the upper one will have the countersunk, the lower will not have countersunk, so no need of countersunk, but you have to inspect it for burrs here. Okay, so this is the second inspection. See, the numbers are coming like this: 1, 2, 3, and then in this branch 4, 5. Okay, like that. So next, when these 2 are come here, now what you are doing, you are locating the plate one on top of 2. See, once it is done here, then we are coming to this branch. This is the third branch. See here, 2 rivets of 3 mm diameter and 10 mm long. So that we will take it, and you bring it into the main line here, and then you insert the rivets. See, inserting rivets also is operation. Locating the plates also is an operation. And then what you do is, then you form the rivet heads with a riveter, and then again you inspect it. That's how it finishes. So this is the way an outline process chart normally in the industries is carried out. Before proceeding to the next topic, I wanted to discuss briefly about the productivity, because in the first lecture onwards we were talking about productivity. Industrial engineering is basically, to increase the productivity in the industries. So that's why what is productivity? You see here, the productivity is the ratio of what is produced to what is required to be produced. You see how much you should produce and how much you should produce will be in the denominator, and how much you have produced. You see, you may have produced less because of some problem, some visitor came and you could not do something, or you are feeling sick, or you didn't do something like that, because of which you produce less number than stipulated amount. That means your productivity is gone low, like that. Okay, like that it is. See, productivity is, here is a definition, is the determinant of efficiency of an enterprise to convert its variable resources into useful finished goods and services. See, it is the determinant of efficiency of the enterprise as a whole. See, if a very productive, productivity of some industry is very good, means what they are able to produce. Actually, what is, like really they should produce that much amount they are able to produce, and more than that. Okay, so in that case, no, their, you can say that their productivity is excellent. Okay, and productivity is a common measure of how well resources are being used, or a measure of the effective use of resources. See, this is normally given by this formula. Productivity is output upon input. It is not, see, it is so simple. It is not that in the numerator it is rupees, denominator it is rupees. Some of the things, are very difficult to estimate and all. Okay, see, your input will be, various resources means what? It can be raw material, it can be machine hours, it can be man hours, it can be other things also. You see, it can be even electricity, even the other fuels that you are using. Your see, indirect costs and all those things may be coming as input, and output is, how many products you are producing and all. You see, maybe, all these things in terms of rupees, if you can convert. See, man hours you can convert it to rupees, machine hours you can convert it to rupees, raw materials you can convert it to rupees, like that. When you convert in terms of rupees, then you may be able to find out a ratio. Okay, and you will come to this value. You will get an estimate of the productivity. Okay, see, the productivity as such, no, it should be high. Well, what is the benefit of having high productivity? High productivity is linked to higher standards of living. Higher standard of living means what? You see, our country is treated as, is counted as a developing country. You see, we are not a rich country. Rich countries are in Europe and in America. So those are the rich countries. See, our standard of living is low. Standard of living, how you measure? You see, how many cars per 100 people you are having, how much of electricity per head you are using, how many doctors per 1,000 people you are living, you are having, how many hospitals you are having, how many kilometers of roads you are having per 1 lakh population. You see, all these are measures of standards of living. You see, if you want to have higher standards of living, higher productivity, is necessary, is essential, because higher productivity is linked with a higher standard of living. Okay, we are aiming at higher standard of living. Okay, how many mobile phones you are having per 100 people or 1,000 people, that also is one way of finding out what is our standard of living. Then higher productivity relative to the competition leads to competitive advantage in the market. You see, if two companies are there, one company is having higher productivity, one company is having lower productivity. That means what? A higher productivity company with a minimum number of with the same amount of raw materials, they are able to produce more things. You see, they will be able to stay in the market for much longer time. And also another thing, for an industry, high relative productivity makes it less likely it will be supplanted by foreign industry. You see, sometimes we are afraid, multinational companies that are coming and they are taking over Indian companies. See, Indian company, if it is running, productively, then they need not fear like that. Okay. Now let us see flow process chart. The first one what we have seen was the outline process chart, and this is flow process chart. A flow process chart is defined as a process chart which sets out the sequence of the flow of a product through various departments by recording the events using the appropriate process chart symbols. You see, the part may be going from one department to another department. All that sequence of flow of the product through different departments. These are all. This is all charted out in this flow process chart. A flow process chart makes use of all of the process chart symbols, because in the previous chart we didn't use. We used only two. What were they? The circle and the square only we used. But here we are going to use the other symbols also, which we have learned before. Okay, there are three types of flow process chart. One is man type, second is equipment type, third is material type flow process charts. Okay, see, now here there is an example. Here again, you see, actually they here in this Nirali publications, in this book, only the this drawing is given, but actually it should have some other details, as I have shown in the example just we know what we saw. You see, as here, the part number, part name, location, and other things were there. Whether it is a present method or proposed method, who charted it, who approved it, these things also should be there. You see, those things, this Nirali Prakash in this book has omitted, but in actual practice it should be there. Okay, so here first let us see man type. Man type means, it is simple. It shows that this flow process is for a man. Okay, whereas material type will be for it will be tracking material. Here we are tracking man. Okay, see, what is the example here? Okay, let us see what. Okay, it records the activities of an operator. It can be an operator, or it can be a peon, or it can be some typist or something like that. You see, normally in industry we are talking means, normally it will be an operator of a machine, or some worker who is working. Okay, but for us to understand, these type of examples they are taking. You see, the task is writing a letter. For that, we are seeing a flow process chart, man type flow process chart. Okay, so first, you see, we start here. So first, what we are showing an arrow. Arrow is for transport. You see, that means he is going to the principal's office. So this person is a typist, you can say, or a steno. So first he gets up from his his table, and he goes to the principal's office. So there next what you have is, you have an operation. Circle means operation, and this operation is 1, whereas this transport, this arrow is 1. This is 1. This is there in the head, there is 1 is there. So here what is he doing? He is taking dictation, because he is a steno. He takes a writing pad, on that he writes letter in shorthand. Okay, he takes dictation, and from there what he does, he goes back to his own seat. So he is going. So this is transport. So this is 2. And here next is type the letter on the computer. So he is doing another operation. So that is why this circle with 2. Then he checks the letter, like spell check, grammar check, or any other thing, properly, you have to indent it and all those things. For that, that is a kind of inspection. So first inspection. Okay, afterwards then you have to take, when everything is fine, you take a printout. It's another operation. Then you put it in a file. Normally to the offices we don't take one paper and go. We should put it in a file folder and take it to the officer. So this is the 4th operation. From there, he takes the file and goes to the principal again. Okay, What for? This is the third transport, transport. Okay, so he goes, he puts it, places the file for signature. Okay, so this is the fifth operation, and then here is a delay. He is waiting. What for is he waiting? He is waiting for checking and signature. See, when the principal checks himself, he ensures whether everything is printed typed properly. He will see, and then he puts a signature. So at that time, this man, principal is doing work for them. For him, no, if we do the flow process chart, it may be in operation, but for this person, our steno, it will be a delay because he is waiting there, he is not doing anything. And then when the principal puts the signature, he goes back to his seat. So again, a non-transport. Okay, and this is the fourth operation, fourth transport, and then finally he puts the paper in the file. Okay, or whatever, or in the envelope. Okay, this is how the man type flow process chart will be. Now let us see material type flow process chart. See, it records what happens to the material, that is how the material is handled or treated. See here, okay, they have not even given a title for it. Okay, now let us start here. This is a from storage. Initially the material is lying in a store, so from the store, and it is transported to the machine. Okay, this is the transport. Okay, and then next is next is we are loading on the machine. If for loading also, the material is getting loaded, so it is an operation. And then machining is done on the material, so it's another operation. And then it goes for inspection. Okay, and then it is inspected. Delay because inspection is going on. Actually, inspection is going on. You see, if it is the inspection for the operator, it will be square, but for the material it is a delay because it is nothing, no operation is being performed on that. Okay, that's why it is delay. From there again to the machine, then operation and inspection. See, operation and inspection, what type of operation and inspection, it is not mentioned, but okay, some operation and inspection is carried out on that. So that's why now this combined operation here. Then again to inspection. Inspection means the material is maybe removed from the machine, and it is taken to the inspecting table or something, and then it is inspected upon. Then here also it should have been square only. Why delay? Delay means before it has reached next machine and it is not taken, then it should be delay. Okay, here instead now you use the square itself. Okay, so he is inspected upon, then again, okay, finally the work is done, so now it should be transported back, and it should be placed in the rack. Okay, and it is kept in the store again, store in the rack in a store. Okay, so there are two storages, 1 2 3 4 5 transports are there, and 1 2 3 operations are there. Actually this is also an operation, they could have given this also number. Okay, then inspections means 1 inspection, 2 inspection, 3 inspections should have been. Okay, like that it should have been. Okay, let us see the next one. Okay, but in industry, how it will be flow process chart. See, it will be having headings like this. Okay, task, inspection of turned shaft, present method. Okay, who it is charted by whom, location, office. Okay, then man type, this material type. Chart starts where, chart ends where. Chart starts student in workshop with the vernier. chart ends students in workshop with vernier, same condition. Whereas for material in goods and chart ends with material in store. Okay, let us start here. Okay, for this is the man type. Now man type to goods received, then inspection the operation, locate the component. This is transport. Okay, that means he is in received the goods or the material, whatever, raw material or whatever. Then locate the component, then clamp the component to the jaw. These are all, this is another operation. Then set the component. See what is he doing? This student is in the workshop with a vernier. Okay, he has to inspect the turned shaft. So he has to take the shaft here, and then he has to hold it in the hand. So that is holding us is locating the component, and then he has to clamp the component in a jaw. So in some fixture he is fixing it, and then he is setting the component. Okay, and then he is visually inspecting the component with the eye. Okay, and then he is measuring the diameter with the help of vernier. Okay, and he is unclamping, and he is he is going to the store, like that. So 1 2 3 4 5 operations are there, and how many inspections? One inspection is there, and 2 transports are there that they have not shown, that also should have been shown here. So this is the man type. Okay, whereas this one here for the material type. Okay, the material is waiting for the operation. Okay, that is the delay. Then it goes to the inspection department. This is a transport one. Then it is set in the jaw. Okay, the thing component is set in the jaw. Okay, that is this operation. Okay, for man here set the component is there. Here for material it is set in the jaw, and then this is inspection. This is the same inspection here. Okay, and then measure the dimensions, then inspection seal, maybe even seal should be put, and then it is taken to stores and it is put in the stores. Okay, now see, one delay is there, one permanent storage is there, one inspection is there, and 3 operations are there. This is how material type will be, material chart will be. Okay, let us next see this flow process chart equipment type. First, no, these two we have seen. One is man type, another is material type. Now we are seeing the equipment type, third type. Okay, inspection of a turn shaft. The same thing charted by somebody, and equipment used is vernier caliper, and location is office. Okay, this is the method is present method, it's not a proposed method. Then chart is equipment type, flow process chart, and then chart starts where after the location, after locating the job, and chart ends after unclamping the job. Okay, see, first initially flow process chart for equipment type. For the equipment, what is the equipment here? Equipment here is the vernier caliper, isn't it? Yeah, so it is waiting for the operation. That means it is to be waiting for picking. Okay, then it goes to the operator's hand. Okay, next is set on the jaw, setting on the jaw of the vernier caliper, then inspect it, then measure the dimensions, inspection is a square, and measuring the dimension for the vernier caliper is a circle, and then it goes to stores, and it is finally put in stores. Okay, this is how it is. You see, if again and again you have to do, first you take it in the morning, repeat it till the shift ends after 8 hours, and then put it in the store. You see, it's like a cyclic loop. It is, it is repeated again and again like that. This is the see, equipment type process chart. Okay, so this is how the process charts are. Okay, now let us go to the two-handed process chart. You see, now two-handed process chart, this is defined as the process chart in which the activities of workers' two hands are recorded in their relationship to one another. That is, the chart records the activities of the left hand and the right hand of the operator while he is doing a job. Okay, see, a time scale is sometimes provided to synchronize the activities of the two hands. Sometimes time scale is sometimes provided, means it is not always provided. Okay, then once the activities have been recorded, they are examined with a view to eliminate wasteful, unnecessary, uneconomical and non-essential motions. You see, this is true, for all the charts. Now what are we doing? We are studying the method study. We are doing the method study. For method study, this is what the aim is, to eliminate all wasteful, unnecessary, uneconomical and non-essential motions only. Okay, the chart is generally used for repetitive operations. When one complete cycle of the work is to be recorded. This chart is repetitive operations, means only once you are doing, you're not interested. In a mass production, when number of things, you are per day, in an 8-hour shift, you are producing some, good number of parts, like, in case of assembling of pen or assembling of watches and such things. You see, these operators are there, they take the different parts and they assemble it, and that is the job they do for 8 hours. Okay, if that is repetitive operation, then you should be doing this study. Otherwise, just now and then, if you do once or twice in an 8-hour shift, there is no point in doing this two-handed process chart, or for that matter any other chart. Okay, the recording in two-handed process charts is done in more detail than in flow process chart. See, in the flow process chart, we are not saying the operator is moving the left hand, moving the right hand. It's only saying, operator fixes, operator walks here, walks there, like that. Okay, the activity that is shown as a single operation in flow process chart, example, assembly of nut and bolt, is broken down into number of activities in two-handed process chart. A two-handed process chart for sharpening of a pencil is shown in the next figure. You see here, two-handed process chart. You see, sharpening of a pencil, that is the title. Okay, see, the chart begins where both hands are free for assembly, and chart ends also with in the same condition, both hands free for assembly. Now there are two sections, left section, right section. The left section is for left hand, the right section is for the right hand, and the description for the left hand is on the left side, on the right hand is on the right side. In the center you have symbols, for two columns of symbols are there, because one column is for left hand, the other column is for right hand. Okay, now what you have to do is the sharpening of a pencil. What operations are, what do you do? You take the sharpener, you take the pencil, you insert the pencil in the sharpener, and then you rotate the pencil and sharpen it, and then you check it whether it is done or not, and then okay, when it is fine, you keep the pencil in the tray. Okay, then you again go to the next one. Okay, this is the cycle that you have to do. Now let us see what the left hand does and what the right hand does, and what symbols we are using. Okay, see, for the left hand, with the left hand you pick up the sharpener. Okay, sharpener means pencil should be made sharp, for that we are sharpening. Okay, so pick up the sharpener. So pick up the sharpener. So this is an operation. And at that time what the right hand is doing, right hand is not doing anything, so it is idle, so it is a delay, it is a temporary delay, that's why delay, temporary storage. Okay, then left hand is taken, then with the right hand you take the pencil. Next, at that time what is left hand is doing, left hand is simply holding the sharpener. So uh, okay, it should not have been a triangle, it could have been even delay also, maybe for a long time they are putting, or it can be, it could have been put in a this thing also, some fixture also, so that's why they are using permanent storage. Okay, then pick the pencil, then you bring the right hand to the left hand where the sharpener is, and then now do the operation of sharpening the pencil. Next, next what you have to take it, you have to transport it, and also transport it, and while transporting you can check it. You see, here two operations should be there. Actually it should have been, okay, checking is circle square, isn't it? Yeah, square, and in that, this arrow, it could have been like that. Then till all this time this left hand is doing nothing, it is simply holding the sharpener. Then now next, the left hand goes to keep the sharpener back in the tray, and then at that time right hand is idle. Then when the left hand is idle, then the right hand is keeping the pencil in the tray. Okay, these are the operations. So these operations for left hand, one, two operations. See, that's what here now in the summary, two circles for left hand, three circles for right hand, four storages for left hand, one storage for no storage. Okay, one delay for left hand, two delays for right hand, and no transport for the left hand, two transports for the right hand. Okay, see, actually when you prepare, when you think and make, it may have a little deviation than this. Okay, see, this is only an example. In real life, in industrial problem, these things will be more, definitely more clearly defined, all those things. Okay, now let us see the next. So this is this is another example. Here it is the two-handed process chart for the assembly of two washers and nut to a bolt. You see, we are having a bolt. For on that, no, you have to assemble two washers and also a nut. So totally how many components are there? Four components are there. Now here four columns are there. See, if first column is for the description of the left hand, second column is for the symbols of the left hand, third column is the symbols for right hand, and fourth column is for the description of the right hand. Okay, now with the left hand what you are doing, move the bolt from the tray to the work area. Okay, this is a transport. Okay, at that time what your right hand is doing, move to first washer. You see, on the left hand side you can have one tray in which bolts are there. On the right hand side there can be tray in which washers are there. So both the hands at the simultaneously they can go to two things, and one takes the left hand takes the bolt, right hand takes the washer. Okay, and brings to the work area. Work area means just in front of you. You see, you are sitting on a table, you are on a stool or on a chair on a, before a table. Okay, now, okay, you see, first initially we have gone to the tray and then grasp the bolt. Let us first see what left hand is doing. Grasp the bolt, then move to the position. Move to the position means this is the assembling area. Then what it does, it holds. This holding, now in case of two-handed chart, holding for a few seconds also may be treated as storage. Okay, now let us see what the right hand is doing. Move to first washer, pick up and grasp the first washer and bring to the position that is the assembling area. Now next is right hand is doing assembling to the bolt. What is left hand doing at the time? It is simply holding. It is not doing anything. It is continuing to hold. You see, in all these operations from 4 to 10, it is simply completing. It is continuing to hold. Okay, assemble the bolt. Then move to the second washer. Then here you may say, at the same time I can pick two washers. Yeah, you can do it, but here only for for education purpose we are studying at that time. Okay. Otherwise you can think like that, one is a ordinary washer, another is a spring washer, both are in two different trays. Okay, you can take like that. So move to the second washer, pick that washer and bring to the position, then assemble it. Okay, then next go for the nut. Nut is placed on the third tray. See, now three trays are there on the right hand side. One tray is there on the left hand side. Left hand side has only the bolt. Right hand side it has ordinary washer, spring washer and the nut. Okay. So now move to the nut. Pick up the nut and then move to the position. Okay. Pick up the nut. Nut is move to the nut, pick up the nut, and after picking up the nut you have to assemble it. Okay, here move to box. Okay, you have to assemble it. After assembling only it should be taken to the box to set it aside. Okay, like that, okay, a little bit of variations, you think logically and and see how this chart can be modified a little. Okay, now let us see another example. 200 process chart for assembling nut and bolt. 200 process chart begins with both hands free and chart ends also with both hands free. Okay, see, the left hand is picking up the bolt and the right hand is idle. And after picking up the bolt, it comes to the assembling area, that they have not shown. They should have shown it. That is shown in more detail here. Each one going, picking and assembling, all those things are there. Okay, and then the right hand is picking up the nut. Here only washers are not there. Then go to the left hand, then assemble it, and after assembling it you have to put it in the tray. That also you should have shown, and the summary here. Okay, and let us see next one. Here, filling ink in a pen. 200 process chart. 200 process chart for filling ink in a pen. Now you students may not even understand what is filling ink in the pen. In some, when we were younger, we used to use ink pens. Okay, you see, okay, now what the left hand is doing, picking the pen, then right hand is removing the cap, picking up the ink bottle, pouring the ink in the barrel, then keep it on the table, then pick up the cap and assemble the cap on the barrel, and then write by pen to check. Inspect, that means it. Then for inspect it should have been inspect. Okay, so this is how another example. Okay, Then this is another example, replacing of mobile battery. Now I'll not be going through this. You just you know just pause it and see for some time. Okay. Okay, we'll stop here. Thank you.